Yeah, hello, hi friends. Today we are going to discuss about diesel cycle and dual cycle, both at a time. Okay. Now let us discuss about diesel cycle. See, what here happened in diesel cycle is, let us assume it is a volume 1, which is at a distance of V1 from the point of origin, and pressure 2, which is at P1. Let us assume it is P2, and here let us assume P1. Here we will assume V2. See, when you see the PV diagram, the pressure is going on, the volume is going on decreases. See, it is going on decreases, negative side. It is going to negative side. Means you can say that easily. Volume is decreasing and pressure is as usually increasing. See, it is going P1 to P2. And at this stage 2 to 3, you can see that the pressure is constant here. See, at 2 to 3, pressure is constant. When it comes to 3 to 4, volume gradually increases and pressure gradually decreases. See, P is inversely proportional to V, 1 by inverse. We can write it as P is inversely proportional to V, then PV is directly proportional to 1, means PV equals to constant, right? PV for gamma, okay? Something we have to keep, so we will keep here gamma, okay? You understood this PV diagram, right? Now let us discuss in TS diagram, where temperature and entropy, how will be the entropy? Yeah, when we come to the temperature T1, the temperature gradually increases. See, I will tell you the common thing. Pressure increases, volume decreases, temperature increases. From these three, we can understand that pressure is directly proportional to temperature, right? Oh, sorry, P is constant here. Sorry, friends. Temperature is constant here. Oh, sorry, P is directly proportional. Entropy is constant. Sometimes in graph you have to assume same thing. Let us assume this in T1, it is T2. Otherwise you will get confused like me. Okay, no problem. This is S1 and let us assume this is S3. See, temperature gradually increases. By this, P is directly proportional to T. Means P by T equals to constant, right? Something for that should be, or leave it at. P by T is directly proportional. P by T is constant, let us assume. And pressure is inversely proportional to volume, right? Then PV for something equals to constant, right? Okay. From this you understand, right? Okay. Now let us go to the real part. How diesel engine will solve problems. At 0 to 1, it is suction, and 1 to 2, the process 1 to 2, the increase this process 1 to 2 is reversible adiabatic compression, because in the piston from bottom to it will go to the top dead center, means BDC to TDC, where compression takes place, because this compression, this is the actual size, but it came to this side, right? Here compression is taking place, so it is called reversible adiabatic compression. Reversible adiabatic compression. Then here heat additional take place, means here we are adding heat, some amount of heat at the constant pressure. Pressure will be constant. Okay. Then 3 to 4, this process is called reversible adiabatic expansion. Why expansion means here from top dead center to the pistons move towards the bottom dead center. It will come to the original position. See, the piston will move up and down like this, right? Once up, once down, once up, once down. Let us assume it is top dead center, it is bottom dead center. When it moves towards top, it is called top dead center, or as per the graph we can write reversible adiabatic compression. When it moves downwards, the piston will expand. BDCI is also called as reversible adiabatic expansion. Okay, cool. Then at from 4 to 1, the constant volume will be there. See, constant volume. C volume equals to constant. Okay. And heat will be rejected here. Heat will be rejected. We will inject heat here 2 to 3 and rejection takes place at 4 to 1. Okay. Hope you all understand about the graph. Now let us find the efficiency. Okay. Or some important formulas we will discuss. Every time they will ask maximum what is the efficiency, right? So we will find the efficiency now. How we will find the efficiency? Okay, as we all know that heat injection takes place at 2 to 3 process and rejection. Okay, rejection takes place at 4 to 1 process, right? Okay, means we all know that efficiency of a diesel cycle or any cycle equals to output power by input power, right? Yeah. What is output power? Let us assume you are injecting Q1 heat. Okay, output power by input power. What is output power? It is a total work, right? For example, we have done a work W1 and here WF, or let us assume WI, WF. W initial, W final means the initial work done and the final work done, which will be high. For example, you are going with a speed 2 km per hour. You suddenly raise the accelerator, then it will increase, right, to 4 km per hour. Then what is the initial 2? What is the final output when we give accelerator? If you give accelerator, the speed of the bike will be increases, right? This is generalizable. In the same way, when the initial work done you will give, which will be greater than or which will be less than the final output, right? See, you are giving 100 degrees temperature to a rice cooker. In house you used to cook now, because assume it is a stove. We have kept a cooker in which we are making a biryani, spicy biryani. Let us assume it is a cooker. It is a pressure cooker. Okay, this one. Your initial temperature is what? Let us assume you are giving T1 equals to 150 degrees centigrade. Okay, let us assume, just assume 150 degrees centigrade. Why? When the pressure cooker, there will be some pressure will be inside due to the pressure cooker. The temperature when you get from the vessel or when you remove the crab after cooking, you may get the final temperature T2 equals to 300 degrees centigrade. Ask me why? Because due to the pressure inside the cooker, it will be increased the temperature by itself. In the same way, when you give W1 initial work done, let us assume some 20 kilojoules work done you have given, but at the outcome it will give definitely 50 kilojoules. Let us assume that one 50 kilo. Okay, means you have to assume that the work done is increased. So, what is the total work done then? What is the output power? Now tell me. Now let us come to the problem. What is the output? The output will be the total work done, right? The total work done divided by the heat you supply. Input power equal to heat you supply. Heat you supply. Okay. Q1. Then here you are injecting Q1 heat. You are getting what Q2 heat. Then what is the total work done you have? From the thermodynamics law, W is directly proportional to Q, right? Sigma W equals to sigma Q. In the same way, W total equals to WE exhaust minus WC by Q1. In the same way, you have injected Q1 heat minus Q2 divided by Q1, which is equals to 1 minus Q2 by Q1. Happy? Okay. Now you have completed the efficiency step. Okay. Now let us discuss some technical terms. As you all know that Q1 equals to MCP T3 minus T2. How you got this one? Q2 equals to MCV T4 minus T1. Right? Okay. If you divide or see that what is how we got this one, I will discuss it while solving the main problems. Okay. You got here, let us assume it has efficiency equals to Q1 minus Q2 by Q1. Okay. It is equation 1. Efficiency of a diesel cycle. Okay. Okay. Efficiency equals to 1 minus Q2 by Q1, right? Efficiency of a diesel cycle equals to 1 minus MCV T4 minus T1 divided by MCP T3 minus T2. Okay? Yeah. In the same way, efficiency of a diesel cycle minus 1 equals to, okay, let it be. Efficiency of diesel cycle equals to 1 minus mass is equal, mass get cancelled, then T4 minus T1 divided by Cp by Cv into T3 minus T2. We all know that R equals to Cp by Cv. Okay, small r, gamma equals to Cp by Cv. Or actually for maximum problem, gamma equals to 1.4. If they had not given the question, you can take gamma equals to 1.4. Therefore, which is equals to 1 minus T4 minus T1 by gamma T3 minus T2. Okay, this is the air standard efficiency of a diesel cycle. Air standard efficiency of a diesel cycle in terms of temperature. This is in terms of heat. Okay, cool. Now we have discussed many problems or lot of things. Now let us discuss the problem. What is the real problem, right? Okay, friends. Now we will discuss the main problematic problem. Now tell me one thing. As we discussed in the Otto cycle, from 1 to 2, it is PV power gamma, right? Same here also. 1 to 2 and 2 to 3 equals to PV power gamma equals to constant. PV power gamma equals to constant. PV power gamma equals to constant. And here pressure equals to constant and volume equals to constant. See, here there will be change in from 2 to 3 process. Here temperature will be increased, so we won't discuss. Here entropy will be constant, S equals to constant, and here Q1 heat will be injected, here Q2 heat will be rejected, rejection, okay. And 3 to 4 at T3 is the maximum temperature, okay. T3 equals to maximum, and T1 is the initial temperature, Ti, okay. It is the main basic points. Now let us discuss from process 1 to 2. What is in the process 1 to 2? As we all know that from process 1 to 2, T2 by T1, okay, T is directly proportional to V, right? Yeah, yeah. Then T equals to V power gamma minus 1. Okay, temperature equals to volume whole power gamma minus 1. From this equation, we can write that from process 1 to 2, T2 by T1 equals to V2 by V1 whole power gamma minus 1. Okay, okay. Then another part, in this part only, V2 by V1 is equals to compression ratio, right? V2 by V1 equals to compression ratio equals to small r. Okay. Then T2 by T1 equals to R power gamma minus 1. Therefore, T2 equals to R power gamma minus 1 into T1. See, in the problem, they will give initial temperature, right? You got T1, okay. Now you have find T2 from this, okay. It is first step. Then second step, PV power gamma equals to constant. Therefore, P1 V1 power gamma equals to P2 V2 power gamma. Okay. Then P1 by P2 equals to V2 by V1 whole power gamma. Right? Therefore, we can write that P1 by P2 equals to compression ratio whole power gamma. Therefore, P1 equals to R power gamma into P. See, they will give P2. See, you have got 2 points, right? T2, oh, sorry, you have got T2 here, right? And P2, P1 here. See, okay, 1 minute, I will change the brush. See, you have got T1 here, T2 here, and T1 here. See, the problem they will ask is such like how means first they will tell in the problem for temperature part I am telling. For temperature part they will say initial temperature, okay, or the temperature at the starting, the temperature at the starting. If it is, if these two types or something they will ask like that which is related to the starting point, then you have to consider it is as T1. From that you have to T2, right? Okay. And when we come to the pressure P1, see, pressure P1, they will give in the question, or they will, I maximum they won't give P1, they will give P2 by telling that maximum pressure. See, maximum pressure. If they tell, or in diesel cycle, maximum pressure means you have to consider P2, or will tell initial pressure. Initial pressure means you have to take P1. Okay, don't be confused. Uh, in the question only they will mention the main points. Okay, please do consider that one. Okay, now you have got P1, T1, V1. If they have given initial volume, you can find. If they hadn't given this V1, then we know that PV equals to MRT. Then P1 V1 equals to MRT1. Or you got P1 now, T1 now, M let us consider if they haven't given mass, take 1 per kg, and R is universal gas constant 0. Sorry, this will be 0.287. Okay, R. From that you have got P1, right? Okay. Now you have found P1, V1, T1. Good. Now process 1 to 2 you understand clearly. Now we will go to process 2 to 3. In process 2 to 3, P equals to constant. It means pressure equals to constant. Then pressure equals to constant means PV equals to MRT. Now only we discuss. Then P2, V2, MR, T2. Okay. Pressure equals to constant, right? Pressure equals to constant at T2. Then V2 by T2 equals to MR by P2. It is a totally a constant, but at M is mass per kg, R is universal gas constant, and P2 in 2 to 3 process it is constant, right? Then V2 by T2 equals to constant. Similarly, we can write V by T equals to constant, right? From 2 to 3 part, okay. Then we can write V2 by T2 equals to V3 by T3. You got V2, yeah. You got T2, yeah. Then you can find V3 and T3. Maximum they will give T3 by telling maximum temperature. See, T3 is maximum temperature. Note this all points like this one, this one, this one, this one. Okay, T3. Now you have find T3. It is one part, and another part is the main part here is okay. T3 by T2 equals to V3 by V2. Any issue here? No issue. And as we all know that V3 by V2 equals to cutoff ratio. Cutoff ratio. What is cutoff ratio? Okay, see, it is V3, right? V3, and here it will be V2, right? Okay, see, V3 divided by V2, which we are calling it as cutoff ratio. Why we call this as cutoff ratio? Mean, see, uh, V3 equals to constant pressure at constant pressure from this distance to this distance, where the in piston, we can, if you have remembered the thermodynamics, you may remember this part. In thermodynamics, here the pressure will be constant. The at this time, the volume between these two is called as the, this is piston. Okay, let us assume it is a piston. The part when it go to the top dead center, it is called as, actually it is the, what we say, cutoff ratio. So we will denote it as rho. Therefore, T3 equals to rho T2. Okay, V3 by V2. You may ask me why we did not discuss this point in Otto cycle. See, in Otto cycle, V3 equals to V2. Constant, right? The graph will be like this, or like this. Okay, 1, 2, 3. V PV graph. See, P2 and here is volume equals to constant. It is Otto cycle. See, volume is constant. Volume is constant. T3 by T2 equals to 1, right? Here T3 equals to T2. See, so we haven't discussed this part in Otto cycle, but only in diesel cycle we got T3, V3 by V2 equals to cutoff ratio rho. Okay, now you understood this part. Okay, from this we got, okay, from the equation 1, what is here? T2 equals to R rho power gamma minus 1 by T1, right? We will substitute here. If they haven't given T2 in the question, means T3 equals to rho into R power gamma minus 1 into T1 temperature. Okay, this also very very important. Okay, now from the process 3, 2 to 3 we have completed. Come, let us go to 3 to 4. See, 3 to, from the process 3 to 4. What is 3 to 4? Reversible adiabatic expansion. Here, PV power gamma equals to constant, right? P1, oh sorry, P3 V3 power gamma equals to constant, right? Then P3 V3 power gamma equals to P4 V4 power gamma. In the same way, P3 by P4 equals to V4 by V3 whole power gamma. See, now let us draw the PV graph here for the diesel cycle. Is 1, 2, 3, 4. See, V4 by V3. Here, see, we know that, till now what we have discussed is V1 by V2 equals to R, compression ratio, and V3 by V2 equals to rho, compression ratio. See, this is our compression ratio, this is cutoff ratio. Why we are telling this is, we can write, see, P3 by P4 equals to V4 divided by V2 into V2 divided by V3 whole power gamma. Is there any change? If we cancel V2, V2, we will get the previous step, right? Okay. In the same way, we will write, see, here volume is constant, right? Then V4 equals to V1, right? Okay, substitute V1 here. V1 by V2 into 1 divided by V3 by V2. You can write like this. Yeah, no issue, right? Okay. This is from this we can write power gamma. Sorry, R into 1 by rho whole power gamma, right? This is equals to R by rho whole power gamma, right? Okay. Therefore, P3 by P4 equals to R by rho whole power gamma. Okay. Now, in the question, maximally they have given P3, which will we got as maximum pressure, or P2, and P4. We have to find P4 from this question, as you have found this all thing, right? Okay. And now, let us go to process. In the same process, we also can write in terms of temperature, right? Let us discuss. T3 by T, okay, T3 by T4 equals to V4 by V3 whole power gamma minus 1, right? Yeah, this is equals to, in the same way, V4 by V2 into V2 by V3 whole power gamma minus 1. Gamma minus 1, see here. Here we are taking gamma minus 1 and there it is gamma. Don't be confused. And it is V1 by V2 into 1 by V3 by V2 whole power gamma minus 1, which is equals to R by rho gamma minus 1. Okay, cool. Now we have to find T4, right? Okay, you can write anything as T3 by T4 equals to R by rho whole power gamma minus 1. It is one part, or you can write as T4 by T3 equals to rho by R whole power gamma minus 1. Then T4 equals to rho by R gamma minus 1 into T3, right? Okay. From this, T3 equals to, I think we have found T3 somewhere. Yeah, T3 equals to this part, right? Rho R power gamma minus 21. Substitute here. Same. Yeah, it will be funny part. Then T4 equals to rho T1 R power gamma minus 1 into rho gamma minus 1 divided by R power gamma minus 1. See, this to get cancelled, and rho here 1 will get cancel. Therefore, T4 equals to rho power gamma T1. Cool. Yeah, it's really cool part. 3 to 4 we have discussed. From this, now you have find P1, V1, P1. Cool. P2, T2. Cool. P3, T3. Cool. P4, T4. Cool. What about volume? What is V2? What is V3? What is V4? If in question they ask volume, you have to find V equals to RT divided by MRT divided by P. See, V2, T2, P2. Okay, you got V2. Same way, V3 equals to MRT3 by P3. How I have got means PV equals to MRT, right? Same way. P4 V4 equals to MRT4. You got P and T, substitute that one, M is 1. If they haven't given mass, R is universal gas constant 0.258, I think. Okay, cool. You got P, this, all things, right? We were discussed at the starting air standard efficiency of a diesel cycle, right? Air standard efficiency of a diesel cycle, right? Diesel cycle, which was equal to at that time 1 minus q2 by q1, which was equals to 1 minus t4 minus t1 by gamma power gamma into t3 minus t2, right? Yeah, we found what was t4. T4 was 1 minus rho power gamma into T1 minus T1 divided by, we also found T3, right? Gamma into, what was this, 3 gamma T1 R power gamma minus 1 minus T2 T1 R power gamma minus 1. Now take out T1 outside, we get 1 minus rho power gamma minus 1 into T1 temperature divided by gamma T1 R rho R power gamma minus 1 minus R power gamma minus 1. Okay, T1 get cancelled, which is equals to 1 minus rho power gamma minus 1 divided by, you can take R power gamma minus 1 into gamma is there, don't forget that one, rho minus 1. It is the air standard efficiency of the diesel cycle. That's it. Thank you. Now in the next video I will discuss about the